From the moment we open our eyes to the sky above, we live with the illusion that Earth is a calm, predictable place. Blue oceans shimmer, green forests stretch for miles, and mountains rise like guardians of eternity. Yet beneath this comforting image lies a very different reality, one far more chaotic, violent, and mysterious than we're often willing to admit. The Earth is not a passive stage on which life unfolds. It is a restless, unpredictable force, capable of creating beauty one moment and unleashing devastation the next. And if history has taught us anything, it's that our planet has no interest in keeping us comfortable. Billions of years ago, Earth itself was born out of fire, collisions and destruction so fierce that our survival as a world was never guaranteed. And even after life managed to take hold, countless species were wiped away by disasters too vast to fight. Earth has erased civilizations with earthquakes, drowned empires with rising seas, and turned thriving landscapes into barren deserts. Yet here we are, fragile humans, daring to believe we've mastered the forces around us. But have we really? Or are we just temporary guests, living on borrowed time at the mercy of powers far greater than we can control? This planet hides secrets that go beyond science, mysteries that stretch into the realms of legend and myth. Lost worlds swallowed by oceans, strange disappearances in places that defy explanation, storms that appear out of nowhere with the strength to topple cities. We like to think we understand Earth, but the truth is, the deeper we look, the more unsettling the picture becomes. Every mountain, every ocean trench, every flicker of light in the sky carries a story we've only begun to uncover. In this journey, we're not just looking at Earth as home, we're exploring it as the ultimate mystery, one that continues to challenge, terrify, and inspire. What you're about to hear isn't just a history lesson or a list of facts. It's the story of a planet that has shaped every moment of our existence and could just as easily erase us tomorrow. Long before forests spread their canopies, before oceans shimmered with life, and long before the first human ever walked the surface, Earth was a world of fire and fury. Its birth was not the gentle creation many imagine, but a violent clash of cosmic forces, a process so destructive and chaotic that the survival of this planet was never certain. To understand Earth's beginning is to peer into a time when space itself was a battlefield, where matter collided, stars exploded, and from the wreckage of violence, a fragile home was forged. Around 4.6 billion years ago, our solar system was nothing more than a swirling disk of dust, gas and debris, left behind by the death of ancient stars. This cloud, known as the solar nebula, spun restlessly, pulling particles together under the invisible grip of gravity. In its center, the sun was igniting, its newborn fire blazing with a light that would one day sustain life. But out at the edges of this chaotic nursery, tiny grains of rock and ice began clumping together, forming larger and larger bodies. These were the seeds of planets, and among them was the early Earth, an infant world still struggling to take shape. The process was anything but peaceful. Earth's earliest moments were defined by collisions so immense that entire worlds were shattered. Chunks of molten rock slammed together at unimaginable speeds, merging, breaking apart, and merging again. Each impact released energy on a scale beyond comprehension, melting vast sections of the growing planet. For millions of years, Earth was more a glowing sphere of magma than a solid surface. Rivers of fire flowed where continents would one day stand, and clouds of toxic gas filled the skies where blue atmosphere now rests. It was a planet in the making, but also a planet constantly on the edge of destruction. One of the most catastrophic events came when Earth collided with a Mars-sized body that scientists have named Theia. The impact was apocalyptic. The collision ejected colossal amounts of rock and metal into orbit, heating the planet so intensely that its surface became a sea of molten fire. From the debris circling Earth, gravity worked its relentless magic once again, slowly gathering the fragments into a companion that would forever change Earth's destiny: the Moon. Without this violent encounter, Earth as we know it might not exist. The Moon has stabilized Earth's tilt, controlled its tides, and influenced its climate for billions of years. What began as destruction ultimately became balance, proving once again that catastrophe and creation are two sides of the same coin. But survival was still not guaranteed. After the Moon formed, Earth endured what scientists call the Late Heavy Bombardment, a period when asteroids and comets rained down endlessly, pummeling the surface, vaporizing oceans before they had the chance to form. and carving out scars that would last for eons. Some impacts were so powerful they could have sterilized the planet entirely, wiping away any fragile beginnings of life. Yet, paradoxically, these same collisions may have delivered water, carbon, and essential elements, the very ingredients that would one day allow life to take hold. The same rocks that threatened to annihilate Earth may have also seeded it with the chemistry of existence. Even as the bombardment slowed, Earth's surface remained hostile. Volcanoes erupted constantly, spewing out gases that thickened the atmosphere into a toxic shroud of carbon dioxide, methane, and ammonia. Lightning storms raged across the skies, striking the molten ground below with relentless fury. To us, this would have been a nightmare, a vision of hell itself. But within this chaos, conditions were being set for something extraordinary. The atmosphere trapped enough heat to keep Earth warm, while volcanoes and asteroid impacts churned the raw materials of chemistry into oceans of potential. Slowly, the molten surface began to cool, solidifying into the first crust. Rain fell for the first time, though it evaporated almost instantly under the still blazing heat. Yet over time, the rain returned again and again, filling depressions, carving out basins, and eventually giving rise to the first oceans. These waters would become the cradle of life, but at this stage, they were lifeless pools, their waves crashing against barren rock under skies choked with poison. Still, compared to the firestorms of earlier eons, Earth was beginning to look more like a planet, and less like an open wound of the cosmos. Even in these early days, Earth was shaped by forces that continue to define it today. Beneath the crust, the mantle churned with heat, driving the movements of tectonic plates that would one day rearrange continents and give birth to mountains. The core, rich in iron and nickel, began to generate a magnetic field, shielding Earth from the deadly radiation of the sun. Without this invisible barrier, the atmosphere would have been stripped away, leaving Earth a barren husk like Mars. Instead, the planet developed a protective shield that allowed water, air, and eventually life to endure. What makes Earth's violent birth so remarkable is not just the destruction it endured, but the delicate balance that emerged from it. A slightly different trajectory, a smaller moon, a weaker magnetic field, and Earth might never have been able to hold on to its oceans or sustain life. The violence was not just chaos, it was precision, a cosmic accident that somehow created the conditions for stability. Out of fire and ruin came the chance for growth, for adaptation, for everything that would follow. And yet, even as Earth cooled and stabilized, it carried scars of its birth that remind us of how fragile it once was. Meteor craters, volcanic plains, and tectonic ridges are all remnants of that turbulent past. We walk on continents that were forged in fire and shaped by collisions. We breathe air created by volcanic outgassing and sustained by processes that began billions of years ago. Every step we take is on the surface of a survivor, a world that should, by all odds, have been destroyed long before we ever arrived. This violent beginning also set the tone for the rest of Earth's story. A planet born in chaos would never be a planet of calm. The same tectonic movements that cooled the crust would later shake cities with earthquakes. The same volcanoes that built the atmosphere would later bury civilizations in ash. The same oceans that formed from endless storms would one day rise and fall, swallowing coastlines. From the very first moment, Earth was never meant to be stable. It was meant to be alive, restless, and constantly reshaping itself. The story of Earth's birth is not just a distant memory locked in stone. It is a reminder of the forces still at work beneath us, forces that could erupt, shift, or collide without warning. To understand Earth's violent origin is to understand why our planet is both beautiful and terrifying, nurturing and destructive. It teaches us that survival is not guaranteed. It must be earned, again and again, in the face of a world that has always been as dangerous as it is generous. And so, when we look up at the moon, we are not just seeing a glowing light in the night sky, we are seeing the aftermath of the collision that nearly destroyed us, but instead gave us the chance to exist. When we hear the rumble of a volcano or feel the trembling of an earthquake, we are feeling the echoes of a planet still alive with the same energy that shaped it billions of years ago. Earth's violent birth was not the end of chaos. It was only the beginning of a story that continues to this day. After Earth cooled from its violent beginnings, oceans spread, continents shifted, and conditions began to stabilize just enough for life to emerge. What started as microscopic organisms swimming in primordial seas would, over the course of billions of years, give rise to some of the largest and most astonishing creatures to ever walk, fly, or swim. The Age of Giants was not just about size, it was about dominance, survival, and the incredible variety of life Earth has nurtured. But as magnificent as these creatures were, their reigns always came to an end, and with each extinction, Earth reminded its inhabitants that survival is temporary and power is fleeting. The story begins in the seas, long before dinosaurs or mammals ever appeared. About 500 million years ago, during the Cambrian explosion, life underwent a sudden burst of diversity. Strange, armored creatures like trilobites crawled along the seafloor, while bizarre predators like Anomalocaris, with its spiked appendages and circular mouth, ruled the oceans. These creatures were unlike anything alive today, alien, almost nightmarish. Yet they thrived in the new ecosystems, testing forms and functions that would eventually shape the blueprint of life as we know it. The seas were Earth's first kingdom of giants, and with time, life only grew larger. By the Devonian period, fish had become masters of the oceans. Some, like Dunkleosteus, reached lengths of 30 feet, armored in bone plates and capable of biting with a force strong enough to crush anything in its path. The oceans teemed with these leviathans, predators that struck fear into anything smaller. It was a reminder that Earth favored not just survival, but also escalation, the endless arms race between predator and prey that drove life to new extremes. At the same time, the first plants began to colonize land, transforming the barren landscapes into green worlds that would one day host towering forests and, eventually, the giants of land. Then came the age most of us picture when we think of giants, the reign of the dinosaurs. For over 160 million years, these creatures dominated Earth's land, seas, and skies. They came in every form imaginable, from the massive sauropods, some stretching over 100 feet long, to the terrifying predators like Tyrannosaurus rex, whose very name has become synonymous with raw power. In the skies, pterosaurs soared with wingspans larger than small airplanes, while in the oceans, reptiles like mosasaurs and plesiosaurs hunted with relentless efficiency. Dinosaurs were not just creatures, they were ecosystems in themselves, shaping and being shaped by the world around them. But size was not limited to dinosaurs alone. Insects during the Carboniferous period, long before dinosaurs, had grown to monstrous proportions thanks to higher oxygen levels. Dragonflies with wingspans over 2 feet filled the skies, and millipedes longer than cars crawled across the ground. Later, in the Ice Ages, mammals took their turn as giants. Mammoths, mastodons, giant ground sloths, and saber-toothed cats dominated vast landscapes, thriving in cold climates that tested every creature's ability to adapt. Again and again, Earth proved it could nurture giants. And again, those giants would face the same fate, extinction. Extinction is as much a part of Earth's story as creation. More than 99% of all species that have ever lived are gone, swept away by events too powerful for them to overcome. 5 major mass extinctions punctuate Earth's history, each one a brutal reset button that erased entire branches of the evolutionary tree. The Permian extinction, often called the Great Dying, wiped out around 90% of species, leaving Earth almost barren. The reasons remain debated: massive volcanic eruptions, shifts in climate, methane release. But the result was the same. Life as it had existed was gone, and new life would rise to take its place. The most famous extinction, however, came 66 million years ago, when an asteroid struck the Yucatan Peninsula with the force of billions of atomic bombs. In an instant, the age of dinosaurs ended. The impact ignited global wildfires, sent shockwaves across continents, and filled the atmosphere with dust and ash that blocked the sun. For years, the planet shivered in darkness, plants withered, and the food chain collapsed. The giants who had ruled for millions of years could not survive. Yet from their ashes, new life found its chance. Small mammals, once insignificant under the shadow of dinosaurs, began to thrive. That moment of destruction paved the way for us. Extinctions remind us of Earth's dual nature, generous in creation, merciless in destruction. Each time, life adapts, evolves, and fills the empty spaces left behind. The age of dinosaurs ended, but it gave way to the age of mammals, which in turn gave rise to humanity. Without extinction there is no renewal. Without destruction there is no transformation. It is a cycle written into Earth's very essence, and one we cannot escape. But extinction is not just a relic of the past, it is a reality of the present. Many scientists believe we are living through a sixth mass extinction, driven not by asteroids or volcanoes, but by humanity itself. Species vanish daily as habitats are destroyed, climates shift, and ecosystems unravel. Just as the dinosaurs fell to forces beyond their control, countless modern species fall to ours. We like to believe we are immune to extinction, protected by our technology and intelligence. Yet history tells a different story. Every giant, every ruler of Earth, eventually meets the same fate. We are not separate from this cycle, we are a part of it. And this is where the story of giants becomes more than history. It becomes a warning. Dinosaurs once believed their reign was eternal, but a single event ended it all. The mammoths once walked in herds across continents, but changing climates erased them. No matter how strong, how intelligent, or how dominant, no species has been exempt from Earth's resets. Humanity may believe itself untouchable, but the truth is that we too live on borrowed time. The very forces that erased giants still surround us, waiting for the right moment to remind us of our place. What makes the story of Earth's giants so compelling is not just their size or their power, but the lessons they leave behind. They show us that dominance is temporary, survival is fragile, and extinction is inevitable if adaptation fails. They also show us the resilience of life, the way it remains, transforms, and flourishes even after catastrophe. Without giants, we would not be here. Without extinctions, the world as we know it would never have existed. Earth is both destroyer and creator, teacher and execution. Its message is clear. Nothing lasts forever, but everything leaves its mark. So when we marvel at the skeleton of a towering dinosaur in a museum, or when we imagine the thunderous footsteps of mammoths on frozen plains, we are not just looking into the past. We are looking at echoes of our own possible future. The giants once thought their world would never change, just as we sometimes believe ours will not. But Earth is always changing, always rewriting its story, and always reminding us that the age of any species, no matter how mighty, is only one chapter in its endless book. Beneath our feet lies a mystery so vast that most of us never think about it. We see mountains, valleys, rivers, and coastlines as permanent fixtures of the Earth, as if they've always been where they are now. But the truth is far stranger. The surface of our planet is not fixed at all. It is alive, restless, and in constant motion. Continents drift like massive rafts, carried by the invisible currents of molten rock below. Oceans open and close, mountains rise and erode, and what looks unshakable today may vanish tomorrow. Earth's crust, the thin skin on which we live, is a dynamic, moving puzzle, and its movements have shaped everything from the air we breathe to the history of life itself. The theory of plate tectonics, now widely accepted, was once a radical idea. A little over a century ago, most scientists believed continents were immovable. Then in 1912, Alfred Wegener proposed his controversial theory of continental drift, suggesting that the continents had once been joined together in a single massive landmass before slowly drifting apart. He was mocked and dismissed because he couldn't explain how such movement was possible. Yet the evidence was undeniable. Identical fossils found on continents now separated by oceans, mountain ranges that lined up perfectly across continents, and ancient climates recorded in rocks that made no sense unless the continents had shifted. Decades later, with the discovery of seafloor spreading and the mapping of mid-ocean ridges, Wegener's idea was vindicated. Earth's surface was indeed moving, powered by the heat within. At the heart of this movement are tectonic plates, huge slabs of rock that cover Earth's surface like a jigsaw puzzle. These plates float atop the asthenosphere, a semi-molten layer of the mantle that behaves like a slow-moving river of rock. The plates move only a few centimeters a year, about as fast as fingernails grow, but over millions of years, these tiny shifts reshape the entire world. Continents collide, forming mountain ranges like the Himalayas, which are still rising today. Plates pull apart, creating rift valleys and new oceans. Others slide past one another, triggering earthquakes along boundaries like California's San Andreas Fault. To live on Earth is to live on a planet that never sits still. The history of these moving plates tells the story of supercontinents, massive land masses that formed, broke apart, and reformed across billions of years. The most famous of these is Pangaea, which existed around 300 million years ago. On this single giant continent, deserts stretched vast and unbroken, while coastal regions teemed with strange life. But Pangaea was not the first. Before it came Rodinia, Nuna, and others. each one assembling and fragmenting in cycles driven by tectonic forces. Every time a supercontinent split, oceans widened, climates shifted, and ecosystems were forced to adapt or perish. These cycles are part of Earth's heartbeat, long rhythms that continue even now. Scientists believe that in 2,250 million years, another supercontinent, sometimes called Pangaea Proxima, will form, altering the face of Earth once again. Mountains are among the clearest signs of this restless crust. The Himalayas, towering higher than any other mountains on Earth, are the direct result of the Indian plate crashing into the Eurasian plate. This collision began around 50 million years ago and continues today, pushing the mountains higher inch by inch. In fact, Mount Everest grows slightly taller every year. Yet while mountains rise, they also fall. Wind, water, and ice slowly wear them down, carrying their remains to rivers and oceans. The Appalachians in North America were once as tall as the Himalayas, but over hundreds of millions of years, they've been reduced to rounded hills. Mountains remind us that nothing is permanent, not even the tallest peaks. Oceans, too, are shaped by tectonic movement. Beneath the waves, vast mountain chains called mid-ocean ridges stretch across the globe, where molten rock rises to form new crust. Here, the seafloor slowly spreads, pushing continents farther apart. The Atlantic Ocean, for example, grows wider every year as the Americas drift away from Europe and Africa. In other places, oceanic plates are forced beneath continental ones in a process called subduction. These zones create deep trenches, such as the Mariana Trench, the deepest point on Earth, and fuel volcanic eruptions that can devastate entire regions. The Ring of Fire circling the Pacific is one of the most active areas on Earth, a direct result of these subductions. The motion of continents has not only shaped landscapes, it has also shaped life. When landmasses split apart, species were separated, evolving independently, and giving rise to new forms of life. When continents collided, ecosystems merged, sparking competition and adaptation. The breakup of Pangaea, for example, set the stage for the diversification of dinosaurs, as isolated populations adapted to different climates. Later, the formation of the Isthmus of Panama connected North and South America, allowing species to migrate and compete in new territory. Life on Earth is deeply intertwined with the restless movements of the crust, and every shift has rewritten the story of evolution. But these movements also bring destruction. Earthquakes, one of the most feared natural disasters, are the direct result of plates grinding against one another. The energy released in seconds can topple cities, collapse bridges, and reshape coastlines. Entire communities live under the constant threat of quakes, especially those along plate boundaries. Volcanic eruptions, too, are fueled by tectonic processes, their ash and lava both destructive and life-giving. While eruptions can bury cities, they also enrich soils, create new land, and even release gases that shape the atmosphere. It is a reminder that Earth's destructive forces are also forces of renewal. Perhaps the most haunting aspect of tectonic motion is its silence. Plates move so slowly that we rarely notice them, yet their consequences are immense. A city built today may one day lie underwater as land sinks or coastlines retreat. Entire continents may drift into new climates, transforming deserts into forests or forests into frozen wastelands. We measure time in decades or centuries, but Earth measures time in millions of years, and in that scale, no mountain, no ocean, and no continent lasts forever. What makes this living skin even more mysterious is how it connects Earth's surface to its deep interior. The movement of plates is driven by heat from the planet's core, heat left over from its violent birth and fueled by radioactive decay. That heat rises, creating convection currents in the mantle that drag plates across the surface. Without this inner fire, Earth would be geologically dead, like Mars or the Moon. Instead, our planet remains active, restless, and alive. This activity has not only shaped the land, it has also helped sustain life. Volcanic outgassing created much of Earth's atmosphere. Plate movement recycles carbon through the crust and atmosphere, and mountain building influences weather and climate. The very habitability of Earth is tied to its moving crust. When we step back and look at the bigger picture, we realize that Earth's continents are not fixed nations or eternal borders. They are travelers, drifting slowly across oceans, colliding, breaking apart, and reshaping the world in ways we can hardly imagine. The surface beneath us is only a thin shell floating on forces far beyond our control, And as history shows, these forces are not gentle. They are relentless, unstoppable, and often catastrophic. To understand Earth's living skin is to see the planet not as static, but as a being in motion. Continents are not permanent. They are chapters in a story still unfolding. Mountains are not eternal. They are fleeting monuments destined to crumble. Oceans are not fixed. They are ever-changing, growing and shrinking with the pulse of the planet. Earth has never been still, and it never will be. The question we must ask is, what happens when the next great shift arrives? What new supercontinent will form? What new mountains will rise? And what civilizations will be buried beneath the changes? Just as life adapted before, humanity too will be forced to adapt, or risk becoming another casualty of a restless world. The surface beneath our feet may feel solid, but it is anything but permanent. Earth's living skin is always moving, always reshaping, and always reminding us that nothing stays the same forever. The oceans cover more than 70% of Earth's surface, and yet for all our technology and exploration, they remain the least understood part of our planet. We often look to the stars in search of the unknown, sending probes to Mars and telescopes into deep space, while overlooking the vast alien world right here on Earth. The deep sea, stretching down into crushing darkness, is a place more mysterious than the surface of the moon. Entire mountain ranges, valleys deeper than the Grand Canyon, and ecosystems unlike anything on land are hidden beneath the waves. The oceans are not just water, they are ancient archives of Earth's history, living laboratories of evolution, and unpredictable engines of climate that can either nurture life or bring devastation. For centuries, humans viewed the sea as endless and unknowable. Early sailors feared falling off the edge of the world or being swallowed by sea monsters lurking in the depths. While those fears may have been based on myth, the truth is that the ocean is filled with creatures so bizarre they might as well be monsters. In the darkness of the abyss, life has evolved in forms that seem to defy nature. Fish with transparent heads, creatures with teeth too large for their mouths, and glowing organisms that produce light in complete darkness remind us that the ocean is a world where the rules of life twist in unexpected directions. At the heart of the ocean's mystery lies the deep sea, the zone below 200 meters, where sunlight no longer penetrates. Beyond that, at depths of thousands of meters lies the abyssal plain, vast flat expanses broken only by trenches and ridges. The pressure here is immense, crushing anything unadapted to its weight. Temperatures drop near freezing, and the environment seems hostile to life. Yet even here, in places where no sunlight reaches, ecosystems thrive. Around hydrothermal vents, cracks in the seafloor where superheated water rich in minerals gushes out, life flourishes without sunlight. Entire communities of organisms live off chemical energy, a process called chemosynthesis, proving that life can exist in conditions far removed from what we think of as normal. These vents are not just scientific curiosities, they may hold the key to understanding life's very origins. Some researchers believe that life on Earth began around hydrothermal vents billions of years ago, where minerals and heat provided the perfect environment for complex molecules to form. If true, then the deep sea is not just alien, it is ancestral, the cradle from which all of life emerged. That possibility also fuels speculation about life elsewhere in the universe. If organisms can thrive in Earth's darkest oceans, might they also exist in the subsurface oceans of moons like Europa or Enceladus? The answers may begin in our own unexplored waters. The ocean floor itself is a dynamic landscape shaped by tectonic forces. Mid-ocean ridges, like the Mid-Atlantic Ridge, are underwater mountain chains where new crust is created, pushing continents apart. Deep trenches, such as the Mariana Trench, plunge more than 11 kilometers down, deeper than Mount Everest is tall. Only a handful of people have ever reached these depths, and each time, new discoveries challenge what we thought we knew. Strange microorganisms live in sediments under extreme pressure, suggesting that even the harshest environments may harbor life, and who knows what larger creatures may lurk in the abyss, waiting to be discovered. Despite decades of exploration, scientists estimate that more than 80% of the ocean remains unmapped, unobserved, and unexplored. The oceans also guard secrets of our past. Beneath their waves lie sunken cities, shipwrecks, and the remains of civilizations lost to rising seas. Stories of Atlantis may be myth, but history shows us that the ocean has swallowed entire worlds. After the last ice age, rising sea levels flooded vast areas where humans once lived, erasing entire coastlines. Today, divers and archaeologists continue to find ruins beneath the sea, reminders that Earth's oceans are both life-givers and destroyers. For ancient cultures, the sea was a boundary between the known and unknown, a source of food and trade, but also a force capable of wiping away everything. That duality remains true even now. Modern science has revealed the ocean's role as the planet's climate engine. Currents driven by differences in temperature and salinity act like conveyor belts, moving heat around the globe. The Gulf Stream, for example, carries warm water north, shaping Europe's climate. If these currents shift or collapse, the impact could be catastrophic. Already scientists warn that melting ice and warming oceans may be disrupting these flows, raising fears of sudden climate shifts. The ocean absorbs vast amounts of carbon dioxide and heat, buffering us against climate change, but this comes at a cost. Warmer waters bleach coral reefs, acidify ecosystems, and threaten the delicate balance that sustains marine life. The oceans may protect us for now, but their capacity is not infinite. The mysteries of the sea also inspire darker speculation. Sailors have long reported strange disappearances in regions like the Bermuda Triangle, where ships and planes vanished under unexplained circumstances. While most cases can be explained by storms, human error, or magnetic anomalies, the persistence of such stories reflects our deep unease with the ocean's unpredictability. Storms can rise suddenly, rogue waves can appear without warning, and whirlpools can drag ships down. Even today, with satellites and weather models, the ocean remains a place of uncertainty. For those who venture out, the sea is both opportunity and danger, and its true nature can turn deadly without notice. Marine biologists continue to discover new species at an astonishing rate. Each expedition reveals creatures no one had imagined, from jellyfish that glow like living lanterns, to giant squid that remain elusive and rarely seen. Legends of sea monsters may have roots in sightings of these rare giants. The colossal squid, for example, can grow to lengths exceeding 15 meters, with eyes the size of dinner plates. For centuries, such animals were thought to be myth, until modern science confirmed their existence. If creatures this large can remain hidden in the depths, what else is out there, beyond our reach? And yet, for all its dangers, the ocean is also the foundation of life on Earth. It regulates our climate, provides food for billions, and produces most of the oxygen we breathe. Microscopic plankton drifting in the currents generate oxygen through photosynthesis, sustaining life on land. Without the oceans, Earth would be unrecognizable, a barren rock incapable of supporting the richness we know. The paradox of the ocean is that it is both a nurturing cradle and a merciless executioner, offering abundance one moment and disaster the next. The more we explore, the more we realize how little we know. Every new discovery suggests that the ocean's secrets run deeper than we imagined. Submarine canyons cut across the continental shelves, some larger than the Grand Canyon, carved by ancient rivers now drowned by rising seas. Underwater volcanoes, called seamounts, rise from the seafloor by the thousands, many still undiscovered. Tsunamis born from undersea earthquakes can devastate coastlines in minutes, their power unleashed without warning. The ocean is a reminder that beneath its surface lies a world vast enough to contain both wonders and terrors beyond imagination. To stand at the shore and gaze across the horizon is to confront the unknown. The waves may look calm, the water endless, but beneath lies a realm still largely untouched, holding the keys to Earth's history and perhaps to its future. We have mapped the surface of Mars more thoroughly than the ocean floor, a fact that should humble us. For all our progress, the greatest frontier still lies beneath our own seas, and every year that passes, the urgency grows to explore, to understand, and to protect this world before its mysteries slip away, or its balance tips against us. The oceans are not silent. They are alive, restless, and powerful. Their secrets remind us that Earth is not a finished story, but an ongoing mystery. To dive into the deep is to enter another world, one that challenges our assumptions and stirs our imagination. The sea has shaped our past, it defines our present, and it will decide much of our future. And as long as most of it remains unexplored, one haunting question lingers. What else is hiding in the depths, waiting to be revealed? Deep beneath our feet, hidden under layers of rock and crust, lies a force so powerful that it has shaped continents, destroyed civilizations, and even altered the course of history. This force is Earth's fiery heart, the molten engine of heat and pressure that never rests. For most people, volcanoes are dramatic mountains that occasionally erupt, spewing fire and ash. But the truth is far more complex and far more unsettling. Volcanoes are not just surface spectacles. They are the direct expression of Earth's inner fire, a reminder that our planet is alive, restless and capable of unleashing devastation at any moment. The story begins in Earth's interior. At the center of the planet lies the core, a sphere of iron and nickel hotter than the surface of the sun. The heat from this core radiates outward, driving convection currents in the mantle above. These slow, powerful movements push tectonic plates across the surface, creating fractures, ridges, and zones where molten rock or magma can rise. Volcanoes are the scars left behind when Earth's inner fire escapes, bursting forth in violent eruptions that can reshape entire regions overnight. To live on Earth is to live on top of a world constantly trying to vent its rage. Volcanoes are scattered across the globe, but they are not random. They cluster along boundaries where plates collide or separate, and in places called hotspots, where plumes of magma punch through the crust. The Pacific Ring of Fire, circling from South America to Asia, is home to more than 75% of the world's active volcanoes. These regions are among the most dangerous on Earth, producing eruptions that can destroy cities and earthquakes that can level landscapes. Yet humans have always settled near them, drawn by fertile soils, mineral riches, and the allure of living on the edge of danger. Throughout history, volcanic eruptions have left scars not just on landscapes but on entire civilizations. In 79 AD, Mount Vesuvius erupted violently, burying the Roman cities of Pompeii and Herculaneum under ash and pumice. Thousands perished in an instant, their final moments preserved in eerie detail. The eruption was so powerful that it altered the surrounding climate for years. In 1815, Mount Tambora in Indonesia unleashed the most powerful eruption in recorded history. The explosion was heard thousands of kilometers away, and the massive cloud of ash blocked sunlight across the globe. The year that followed, 1816, became known as the year without a summer. Crops failed, famine spread, and societies were thrown into chaos. A single eruption halfway across the world had plunged millions into crisis, proving that Earth's inner fire can affect every corner of the globe. Modern times have brought similar reminders. The 1980 eruption of Mount St. Helens in the United States reduced the mountain's height by hundreds of meters and unleashed a lateral blast that flattened entire forests. In 1991, Mount Pinatubo erupted in the Philippines, releasing so much ash and sulfur dioxide that global temperatures dropped for several years. These eruptions demonstrate a sobering truth. Volcanoes are not just local events, they are planetary forces, capable of altering the very climate we depend on. But volcanoes are not only agents of destruction, they are also creators. Much of Earth's land exists because of volcanic activity. Islands like Hawaii were born from eruptions, their lush landscapes built on foundations of lava. Over millions of years, volcanoes have released gases like water vapor, carbon dioxide, and nitrogen, which helped form Earth's atmosphere. Without volcanic activity, life as we know it might never have existed. Even today, volcanic soils are among the most fertile in the world, sustaining agriculture that feeds millions. The paradox of volcanoes is that they destroy and create in equal measure, erasing civilizations while laying the foundations for new ones. Beneath the surface, the dangers are even greater than what we see. Supervolcanoes, massive volcanic systems capable of eruptions thousands of times more powerful than ordinary ones, are among the most terrifying forces on Earth. The Yellowstone caldera in the United States is one such supervolcano sitting atop a magma chamber so vast that if it erupted fully, it could blanket much of North America in ash and trigger a global catastrophe. Scientists believe eruptions of this scale have occurred in the past, leaving scars that can still be seen in the geologic record. While the chances of such an event happening in our lifetime are low, the possibility is real enough to remind us how fragile human civilization is in the face of Earth's fire. Even smaller volcanic systems can produce strange and deadly phenomena. Pyroclastic flows, fast-moving clouds of ash, gas and rock, can race down slopes at hundreds of kilometers per hour, incinerating everything in their path. Lahars or volcanic mudflows can bury towns under thick sludge, long after an eruption has ended. Toxic gases like carbon dioxide can seep silently from volcanic vents, suffocating animals and people without warning. In 1986, Lake Nyos in Cameroon released a cloud of carbon dioxide from volcanic activity beneath the lake, suffocating more than 1,700 people in nearby villages. These hidden dangers show that volcanoes do not need to erupt spectacularly to kill. They can strike quietly without fire or lava. Volcanoes also play a role in shaping myths and legends. Ancient cultures often saw them as the anger of gods, or the gateways to the underworld. In Hawaii, eruptions were linked to Pele, the goddess of fire. In Japan, Mount Fuji became a sacred symbol, its volcanic origins tied to spiritual power. These myths reflect a truth that transcends science. Volcanoes inspire awe because they remind us of forces beyond human control. To watch lava flow, to hear the roar of an eruption, is to witness the raw power of Earth itself. Today, scientists monitor volcanoes closely, using satellites, seismographs, and gas sensors to predict eruptions. While progress has been made, volcanoes remain unpredictable. Some give weeks of warning before erupting, while others explode without notice. Technology can reduce the risks, but it cannot eliminate them. For the millions who live near volcanoes, the threat is constant, and the choice to stay is often a gamble between danger and survival. Yet despite the risks, we cannot separate ourselves from volcanoes. They are part of the Earth system, part of the processes that sustain life and shape landscapes. Without them, our planet would be geologically dead, a silent rock adrift in space. With them, Earth is alive, creative and ever-changing. To understand volcanoes is to understand the fiery heart of our world, a heart that beats with both destruction and creation. But perhaps the most unsettling thought is this: Earth's inner fire will never stop. Long after humanity is gone, volcanoes will continue to erupt, continents will continue to shift, and new landscapes will rise from molten rock. Our civilizations, our cities, even our monuments will one day be reduced to ash or buried beneath new land. Volcanoes are reminders that nothing we build is permanent, that the ground beneath us is alive, and that Earth itself has the final word. The fiery heart of Earth is both a gift and a threat, a reminder of our planet's power and unpredictability. It has shaped the world we live in, given us the air we breathe and the land we stand on. But it has also erased entire civilizations in moments. To look into the glowing crater of a volcano is to stare directly into the planet's soul, into the restless fire that has defined Earth since its birth. And while we may fear it, we must also respect it, for without it, there would be no life at all. Few natural events strike fear into the human heart quite like an earthquake. Unlike storms which announce themselves with clouds and winds, or volcanoes which rumble and smoke before they erupt, earthquakes often come with no warning. One moment, life feels secure, the walls around us stable, the ground beneath us firm. The next, the earth shudders violently, buildings sway and entire landscapes shift in seconds. The terrifying truth is that the ground we walk on is never as solid as we believe. Earthquakes are the sudden release of unimaginable energy stored deep within the planet, the result of tectonic plates grinding, colliding and slipping against each other. They remind us that the Earth is alive and that even the foundations we rely on most can betray us in an instant. At their core, earthquakes are born from stress. Tectonic plates are constantly in motion, driven by heat from the Earth's mantle. These plates may lock together at their edges, building tension over decades or even centuries. When that tension exceeds the strength of the rocks, it releases suddenly in the form of seismic waves, ripples of energy that radiate outward, shaking everything in their path. The point underground where the rupture begins is called the focus, and the spot directly above it on the surface is the epicenter. From there, the shock waves travel outward, toppling structures, splitting roads, and sometimes triggering tsunamis that spread destruction far beyond the quake's origin. History is filled with earthquakes that reshaped entire societies. In 1556, the deadliest earthquake in recorded history struck Shaanxi, China, with a magnitude estimated around 8. It reduced entire villages to rubble and killed more than 800. In 1906, San Francisco was nearly leveled by a massive quake, and the fires that followed, forcing the city to rebuild almost from scratch. More recently, the 2011 earthquake in Japan, one of the most powerful ever recorded, triggered a tsunami that devastated coastal towns and caused a nuclear disaster at Fukushima. Each event demonstrates how earthquakes can ripple through every layer of society, not just destroying lives and buildings, but reshaping politics, economies, and the course of history itself. What makes earthquakes especially terrifying is their unpredictability. Unlike hurricanes or volcanic eruptions, they offer little to no warning. Scientists can map fault lines and estimate where quakes are likely, but they cannot predict when or how severe the next one will be. Entire cities live under constant threat, knowing that disaster could strike in the next century or in the next minute. In California, millions live along the San Andreas Fault, where the Pacific and North American plates slide past one another. Experts warn that a big one could devastate the region at any time. Similarly, in Istanbul, Turkey, the North Anatolian Fault lurks dangerously close to millions of people, and scientists warn that it is overdue for a massive quake. Humanity continues to build its greatest cities in the shadow of these geological ticking clocks, gambling with forces far beyond its control. The power of earthquakes doesn't end with shaking ground. They often trigger secondary disasters that can be even more deadly. Landslides bury villages in moments, dams collapse under sudden stress, and fires spread uncontrollably when gas lines rupture. Tsunamis, born from undersea earthquakes, can cross entire oceans and strike without mercy. The 2004 Indian Ocean earthquake, a magnitude 9.1-9.3 event, created waves over 30 meters high that killed more than 230,000 people across 14 countries. It was one of the deadliest natural disasters in human history, a reminder that earthquakes can unleash devastation far beyond their epicenter. Yet for all their destruction, earthquakes also reveal the incredible resilience of life and civilization. In the aftermath of quakes, communities rebuild stronger, learning from past failures. Engineers design earthquake-resistant buildings. Architects study how structures can sway rather than collapse, and governments implement warning systems to save lives. Japan, scarred by centuries of seismic disasters, has become a leader in earthquake preparedness, with buildings that flex and sway during tremors, and systems that alert people seconds before the shaking begins. Those few seconds may not sound like much, but they can mean the difference between survival and death in a collapsing city. Beyond their human toll, earthquakes also play a role in shaping the earth itself. They build mountains, form valleys, and carve landscapes. The Himalayas, still rising today, are the result of the Indian plate colliding with the Eurasian plate, a clash that triggers frequent and devastating earthquakes in the region. The shifting of faults can redirect rivers, create new lakes, or permanently alter coastlines. In that sense, earthquakes are not just destructive, they are part of the planet's creative force endlessly reshaping its surface. There is also a more mysterious side to earthquakes, one that continues to spark debate. Throughout history, strange phenomena have been reported before and during quakes. Glowing lights in the sky, unusual animal behavior, even eerie sounds from deep underground. While some of these can be explained, such as animals sensing vibrations before humans can, or rocks generating electrical discharges under stress, others remain less certain. These mysteries add to the aura of unpredictability, making earthquakes not just a physical danger but a source of enduring fascination and fear. Some scientists also warn of the potential for earthquakes to trigger cascading effects on a global scale. Megaquakes, those above magnitude 9, release energy so vast that they can shift the Earth's axis slightly and alter the length of the day by milliseconds. While these changes are small, they reveal the incredible power locked within the planet's crust. Earthquakes may be local in their destruction, but their reach can extend to the entire globe. Living with earthquakes requires a delicate balance of respect and preparation. People cannot stop the ground from shaking, but they can learn to coexist with it. Ancient civilizations often treated earthquakes as messages from the gods, signs of divine anger or warnings of impending doom. Today, we know they are the result of natural forces, but the awe they inspire remains the same. To feel the earth move beneath your feet is to realize just how small and fragile human existence is compared to the forces of geology. And yet there is another lesson hidden in earthquakes, a reminder of impermanence. The cities we build, the monuments we carve, and the lives we live all rest on foundations that can crumble in seconds. Nothing is as solid as it seems. The ground we trust every day is not permanent but alive, shifting slowly until one day it jolts violently to remind us of its power. Earthquakes are not anomalies, they are part of the natural rhythm of the planet, a rhythm that cares nothing for human time or ambition. Perhaps the most unsettling truth is that the greatest quakes may still be ahead. Fault lines around the world continue to accumulate stress, and eventually they will release it. It may happen tomorrow, or it may happen centuries from now, but the certainty is that it will happen. Humanity has no choice but to prepare, to build with foresight, and to remember that the earth does not promise stability. It only promises change. The shaking ground beneath us is a constant reminder of where we live, not on a stable platform, but on a restless, ever-moving planet. Earthquakes are the voice of the Earth's interior, speaking in rumbles and roars, reminding us that beneath the surface lies a force we can never control. To live here is to live with risk, but it is also to live with the awareness that our world is alive, dynamic and ever-changing. Every tremor, every crack, every aftershock is part of a story that began billions of years ago and will continue long after we are gone. The Earth shakes because it must, and all we can do is hold on, adapt and respect the restless ground beneath our feet. When most people picture danger on Earth, they think of fire, storms, or earthquakes. Ice, by contrast, seems harmless, cold, still, even lifeless. But in reality, the frozen extremes of our planet are among its most powerful and unforgiving forces. Glaciers, ice sheets, and the cycles of ice ages have shaped continents, buried landscapes, and rewritten history. They lock away secrets millions of years old, preserve the remains of vanished worlds, and hold the potential to reshape the future in ways we are only beginning to grasp. Ice is not passive, it is dynamic, destructive, and full of mystery. To understand Earth is to understand the silent grip of its frozen extreme. Glaciers are rivers of ice that move with a patience almost impossible to imagine. To the eye they seem motionless, frozen in time, but in reality they flow slowly downhill, carving valleys, grinding mountains into dust, and reshaping entire landscapes. Over thousands of years, glaciers have sculpted much of the world we see today. The Great Lakes in North America were carved by glaciers, as were the fjords of Norway and the U-shaped valleys of the Alps. These colossal sheets of ice act like natural bulldozers, dragging rock and soil as they advance and leaving behind new terrain when they retreat. What looks like permanence in mountains and valleys is often just the latest chapter in a story written by ice. But glaciers are only part of the story. On a larger scale, the planet has been locked in ice ages, periods when massive ice sheets covered much of Earth's surface. The most recent, known as the last glacial maximum, peaked about 20. Ice covered North America, Europe, and Asia, burying entire regions under kilometers of frozen weight. Seas shrank as water was trapped in ice, exposing land bridges that allowed humans and animals to migrate across continents. The world was colder, harsher, and unrecognizable compared to today. When the ice retreated, it reshaped everything, raising sea levels, drowning coastal plains, and altering climates across the globe. The influence of ice ages on human history is profound. As the glaciers retreated around 12,000 years ago, fertile lands opened up, giving rise to agriculture and the dawn of civilization. But the melting ice also drowned ancient coastlines, erasing early settlements forever. Some researchers believe myths of great floods in cultures around the world may trace back to this period, when rising seas swallowed entire regions. The frozen past is not just a record of climate, it is a record of humanity's earlier struggles and adaptations. What makes glaciers even more fascinating is what they hide. Ice acts as nature's time capsule, preserving the past in layers that build year after year. Scientists drilling into Greenland and Antarctica's ice sheets have uncovered bubbles of ancient air, trapped for hundreds of thousands of years. These tiny samples reveal the composition of Earth's atmosphere long before humans walked the Earth, offering a window into climates past. Through ice cores we know of cycles of warming and cooling, patterns of carbon dioxide and methane, and evidence of volcanic eruptions that shook ancient skies. But ice preserves more than air. It can hold entire organisms. In Siberia, frozen mammoths have been unearthed, their fur, flesh, and even stomach contents preserved in astonishing detail. In other cases, bacteria and viruses long thought extinct have been revived after tens of thousands of years in ice, raising unsettling questions about what else may still lie dormant beneath frozen layers. The danger of melting ice is not confined to the past. Today, glaciers and ice sheets are retreating at alarming rates as global temperatures rise. The Greenland ice sheet is losing billions of tons of ice each year, and Antarctica's ice shelves are breaking apart faster than expected. This melting feeds directly into rising seas, threatening coastal cities worldwide. Scientists warn that if Greenland and Antarctica were to melt entirely, sea levels could rise by more than 60 meters, submerging much of modern civilization. While such a scenario would take centuries, even smaller rises are enough to displace millions, flood fertile lands, and destabilize economies. Ice is not just a relic of history, it is a force shaping our future. Yet glaciers hold more than threats. They are also sources of life. Rivers fed by melting glaciers supply fresh water to billions of people across Asia, South America, and beyond. The Himalayas, often called the Third Pole, contain massive glaciers that feed rivers like the Ganges, Yangtze, and Mekong, lifelines for countless communities. As these glaciers shrink, the risks grow. At first, melting increases river flows, raising the risk of floods. But over time, as glaciers retreat further, water supplies may dwindle, leading to droughts and conflicts. What seems distant and frozen is in fact central to human survival. The mysteries of ice extend into legends and myths. Stories of frozen lands, hidden cities, and ancient beings encased in glaciers appear across cultures. In some myths, ice is seen as a prison, locking away dangerous forces. Modern science sometimes echoes these tales. Imagine ancient pathogens trapped for millennia in permafrost, waiting for the thaw to set them free. In 2016, a heatwave in Siberia thawed permafrost and released anthrax spores from the carcass of a reindeer buried decades earlier, killing dozens of animals and sickening humans. If diseases can survive decades, what about strains frozen for thousands of years? The idea that ice could unlock forgotten threats is no longer just science fiction. There is also the unsettling possibility of sudden ice-related disasters. Glacial lakes formed when meltwater pools behind fragile walls of ice or rock can burst with catastrophic force, unleashing floods that sweep away everything in their path. Known as glacial lake outburst floods, these events have destroyed villages in the Himalayas and Andes. In other cases, giant chunks of ice break off from glaciers in sudden collapses, creating tsunamis in mountain lakes or even the open ocean. The quiet stillness of glaciers hides a volatile nature, capable of sudden, lethal violence. For all its dangers, ice also inspires awe. Polar landscapes, with their endless white horizons, shimmering auroras, and frozen silence, remind us of Earth's extremes. These places seem untouched by time, as if they belong to another world. Yet even here, life persists. Penguins, polar bears, seals, and countless microorganisms have adapted to survive in conditions most species cannot endure. In the frozen ocean, under the ice, ecosystems thrive, sustained by microscopic algae and strange creatures of the deep. The resilience of life in frozen extremes shows us that even in the harshest conditions, nature finds a way. The frozen parts of our planet are more than landscapes, they are warning signs. They show us how fragile Earth's balance is, how easily climates can shift, and how deeply our future is tied to forces beyond our control. The ice sheets of Greenland and Antarctica are not distant curiosities. They are guardians of sea levels, climate, and stability. As they melt, they are sending us a message, one written in floods, storms, and shifting weather. The frozen extremes are not as permanent as they seem. To look at a glacier is to look at time itself, a monument carved from countless winters and unbroken patience. To walk on an ice sheet is to stand on history, compressed layer upon layer, holding secrets of worlds long gone. But to see them retreat is to confront the fragility of our world, to realize that the very forces that shaped civilizations can also unmake them. Ice is both past and future, both guardian and threat, both life-giver and destroyer. Perhaps the most haunting truth is this: ice has always dictated the fate of Earth, and it will continue to do so. Entire species have risen and fallen under its grip. Civilizations have flourished in times of retreat and struggle during advances. And now, as glaciers shrink faster than ever before, we are forced to ask ourselves whether we are ready for what the frozen extremes may unleash. The story of ice is not just about what lies hidden in the past, it is about what waits ahead, and whether we are prepared to face it. When the skies darken, winds howl, and the air grows heavy with tension, humanity is reminded that weather is not just background scenery, it is a force capable of reshaping lives in hours. Storms in all their forms are among Earth's most chaotic displays of power. They can arrive suddenly, tearing apart everything in their path, or builds slowly, unleashing devastation on a scale that dwarfs human efforts to resist. From hurricanes that churn across oceans like spinning giants, to tornadoes that appear without warning, ripping through towns with surgical ferocity, storms are the living expression of Earth's atmosphere in turmoil. They are beautiful, terrifying, and utterly beyond our control. Hurricanes, also called cyclones or typhoons depending on the region, are perhaps the most dramatic of these forces. Born from warm ocean waters, they are colossal engines of energy, fueled by heat and moisture. As air rises and condenses into towering clouds, winds spiral inward, tightening around a calm but deceptive eye. Once unleashed, a hurricane can stretch hundreds of kilometers across, with winds powerful enough to flatten buildings and storm surges capable of swallowing entire coastlines. The devastation of Hurricane Katrina in 2005 showed the world how fragile even great cities can be. New Orleans, protected by levees and surrounded by water, was overwhelmed as storm surges broke defenses and left much of the city underwater. Thousands lost their lives, and the disaster exposed not only the raw power of nature, but also the vulnerabilities of human systems built to resist it. Tornadoes, though smaller in scale, are no less terrifying. They form when conditions in the atmosphere align just right, producing violent funnels of rotating air that touch down with speeds exceeding 300 kilometers per hour. Unlike hurricanes, which can be tracked days in advance, tornadoes can appear within minutes, leaving little time to escape. They carve paths of destruction through neighborhoods, tossing cars like toys and reducing homes to splinters. The tornado outbreak in the United States in April 2011 remains one of the most violent in history, producing hundreds of twisters that killed over 300 people. Survivors describe the sound as that of a freight train, a roar of chaos that gave no mercy. What makes storms even more unsettling is their unpredictability. Despite advances in forecasting, no model can fully capture the chaotic complexity of Earth's atmosphere. Storms can shift paths suddenly, strengthen in hours, or die out unexpectedly. The unpredictability adds to their menace, leaving entire regions in suspense, unsure whether they will face destruction or be spared. This uncertainty keeps communities on edge, especially in regions like the Caribbean, Southeast Asia, or the American Midwest, where storms are a constant threat. Yet storms are not only destroyers, they are also vital to Earth's balance. Hurricanes help transport heat from the tropics toward the poles, regulating global temperatures. Storms stir the oceans, bringing nutrients from the depths to the surface, fueling marine ecosystems. Rainstorms replenish rivers and aquifers, sustaining agriculture and life itself. Without storms, Earth's climate would stagnate, ecosystems would collapse, and life would falter. The paradox of storms is that they are both essential and deadly, a reminder that the same forces that sustain life can also take it away. Climate change is intensifying the chaos. Warmer oceans provide more fuel for hurricanes, making them stronger and wetter. Rising sea levels magnify the impact of storm surges, flooding coastal cities more easily. In recent years, hurricanes like Harvey, Irma, and Maria have left trails of destruction that highlight how storms are becoming deadlier in a warming world. Tornadoes, too, may be shifting in frequency and geography, appearing in regions less prepared for their sudden violence. The atmosphere, once relatively stable, is becoming more unpredictable, and with it, storms are evolving into even greater threats. But storms are not just physical phenomena. They also shape culture, history, and myth. Ancient peoples often saw them as the anger of gods, symbols of divine wrath or punishment. Thunder and lightning became tools of Zeus in Greek mythology, Thor's hammer in Norse legend, and the voice of gods in countless traditions. Even today, the awe and fear storms inspire are woven into human imagination. Stories of ships lost at sea, cities destroyed by floods, and heroes braving the tempest reflect our uneasy relationship with weather. We may understand the science now, but storms still command reverence as forces beyond human reach. Storms also reveal human vulnerability. Modern cities with skyscrapers, highways, and grids of electricity may seem resilient, but when storms strike, the illusion of control shatters. Power grids collapse, communication fails, and entire societies can be thrown into chaos. In 2012, Hurricane Sandy flooded parts of New York City, shutting down subways, cutting power, and transforming the world's financial hub into a fragile, waterlogged shell. For days, millions were left in darkness, reminded that even the most advanced societies are helpless when nature decides to unleash its fury. There is also the haunting phenomenon of superstorms, events so extreme they seem almost apocalyptic. These rare storms driven by perfect conditions can release more energy than all the nuclear weapons on Earth combined. The most powerful hurricanes have winds exceeding 300 kilometers per hour and rainfall that can trigger floods lasting weeks. When such storms strike densely populated areas, the results are catastrophic, displacing millions and costing billions in damages. The question scientists now ask is not whether more superstorms will come, but how often and how prepared we will be. Yet in the aftermath of chaos, storms often reveal resilience. Communities come together, neighbors help neighbors, and humanity shows its capacity to rebuild. Storms destroy, but they also remind us of the fragility of life and the importance of unity in the face of disaster. For those who survive, storms are etched into memory forever, their sounds and sights impossible to forget. They become part of personal history, reminders of how close survival and destruction can be. Beyond hurricanes and tornadoes, storms take countless other forms. Blizzards bury entire regions under meters of snow, paralyzing cities and cutting off lifelines. Dust storms turn day into night, swallowing landscapes in walls of sand. Hailstorms pummel crops and cars with ice bullets from the sky. Each variation is a reminder that the atmosphere is a restless, shifting entity, capable of producing chaos in endless forms. No corner of Earth is safe from storms, whether it's the deserts of Africa, the plains of America, or the islands of the Pacific. Chaos can descend at any moment. Storms of chaos are not just events, they are teachers. They remind us that for all our technology, wealth, and ambition, we remain vulnerable to forces older and greater than ourselves. They strip away illusions of permanence, showing that cities, farms, and even entire nations exist at the mercy of Earth's atmosphere. They remind us that survival has always depended on respect for nature, for the planet, and for the power that storms represent. The next time the skies grow dark, thunder shakes the air, and winds scream through the night, remember this: storms are not accidents. They are the natural expression of a restless world, a cycle of creation and destruction that has shaped Earth for millions of years. They can terrify, they can destroy, and they can humble us, but they also remind us that we are living on a planet that is alive, unpredictable, and endlessly powerful. And as long as storms continue to rage, humanity will continue to live in their shadow, hoping to withstand their fury and survive their chaos. When we think about threats to life on Earth, we usually look inward: volcanoes, earthquakes, storms, floods. But some of the deadliest dangers our planet has ever faced have come not from within, but from the skies above. Earth does not float through space alone. It's part of a cosmic shooting gallery, constantly bombarded by rocks, ice, and debris left over from the birth of the solar system. Most of these pieces burn up harmlessly in the atmosphere as meteors flashing across the night sky. But every so often, one arrives that is large enough to survive the plunge, strike the ground, and unleash devastation on a scale almost beyond comprehension. These cosmic strikes have shaped Earth's history, altered its landscapes, and even rewritten the story of life itself. The most famous impact in history is tied directly to the end of the dinosaurs. Around 66 million years ago, a massive asteroid roughly 10 kilometers wide slammed into what is now the Yucatan Peninsula in Mexico. The energy released was equivalent to billions of nuclear bombs, vaporizing everything near the impact site instantly. The explosion sent shockwaves around the globe, triggered earthquakes and tsunamis, and ignited massive wildfires. But the deadliest effect came from the dust and debris hurled into the atmosphere. For months, perhaps years, sunlight was blocked, plunging the planet into darkness. Plants withered, ecosystems collapsed, and nearly 75% of all species, including the mighty dinosaurs, vanished forever. The crater, now known as Chicxulub, remains buried beneath layers of rock and sediment, the scar left by one of the most catastrophic days in Earth's history. Yet Chicxulub was not the only impact, nor the largest. Earth's surface carries scars of craters far older, and sometimes even more massive. The Vredefort crater in South Africa, more than 2 billion years old, measures nearly 300 kilometers across, making it the largest known impact structure on the planet. Another, the Sudbury Basin in Canada, formed 1.8 billion years ago was so violent that it spewed molten rock across vast regions and altered Earth's crust permanently. Impacts like these may not be remembered in detail, because they happened long before complex life emerged, but their effects were profound. Some scientists believe large impacts may even have influenced the evolution of life, shaping the path that eventually led to humans. What makes cosmic strikes particularly terrifying is their suddenness. Unlike climate change, which unfolds over decades, or tectonic shifts that take millions of years, an asteroid impact can destroy everything in seconds. Civilizations rise and fall over centuries, but one large rock from space could erase all of human history in a single day. The randomness of these events adds to the unease. Earth has no shield, no guarantee of safety. Space agencies scan the skies for near-Earth objects, tracking asteroids that might one day cross our orbit. Thousands have been identified, but countless smaller ones remain unseen, lurking in the dark. A rock just a few hundred meters across could wipe out an entire region. One several kilometers wide could end civilization as we know it. We've had reminders in modern times that cosmic impacts are not just ancient history. In 1908, a massive explosion leveled 2,000 square kilometers of Siberian forest in what is now known as the Tunguska event. No crater was found, because the object, likely a comet or asteroid, exploded in the atmosphere before hitting the ground. Had it occurred over a city instead of a remote wilderness, millions would have died instantly. More recently, in 2013, a meteor about 20 meters wide exploded over Chelyabinsk, Russia, with a force equivalent to 30 Hiroshima bombs. Windows shattered across the city, injuring over 1,000 people. And that was from a relatively small rock, one too tiny to have been detected in advance. Imagine what a larger one could do. Impacts also carry with them an eerie duality. They destroy, but they also create. Many scientists believe impacts delivered much of the water and organic molecules that helped life first take root on Earth. In that sense, asteroids may be both killers and creators. They ended the reign of the dinosaurs, but in doing so cleared the way for mammals to rise, eventually leading to humans. Cosmic strikes are a brutal reminder that extinction and opportunity are sometimes two sides of the same coin. The possibility of future impacts is not speculation. It is certainty. Earth will be struck again. The only question is when and how large. Space agencies like NASA and ESA are developing planetary defense systems, attempting to find ways to deflect asteroids before they hit. In 2022, NASA's DART mission successfully altered the orbit of a small asteroid, proving that deflection is possible. But scaling that technology up to stop a truly massive rock remains a monumental challenge. Humanity has only just begun to grapple with the reality that our survival may one day depend on our ability to push away a celestial bullet. Beyond science, cosmic strikes have also inspired fear and myth. Cultures throughout history have told stories of fire falling from the sky, gods hurling stones of judgment, or stars crashing to Earth as omens of doom. To ancient peoples, the sudden appearance of a blazing meteor must have been terrifying, a sign that the heavens themselves were unstable. Even today, the image of a world-ending asteroid remains embedded in our imagination, from apocalyptic movies to survival scenarios. The difference is that we now know such events are not just fantasy, they are part of Earth's very real past, and possibly its future. What makes the threat so haunting is its scale. An earthquake can destroy a city, a volcano can devastate a region, but an asteroid impact can end civilizations or even wipe out life itself. The randomness of it, that a rock tumbling through space could erase all of human achievement, reminds us of how fragile and temporary our existence truly is. Every day, Earth spins through a cosmic shooting gallery, shielded only by luck and the thin layer of atmosphere above us. The fact that humanity has thrived for thousands of years without a catastrophic impact may be less about safety and more about chance. And yet, cosmic strikes also remind us of the resilience of life. Earth has been hit countless times by rocks that boiled oceans, scorched skies, and wiped out species. But still, life persisted. New species emerged, ecosystems recovered, and evolution continued. In the grand cycle of destruction and creation, cosmic strikes are simply another chapter in Earth's story. For humans, however, the stakes feel more immediate. We are the first species to not only recognize the threat, but to potentially do something about it. The question is whether we will act before it's too late. Perhaps the most chilling thought is this: the dinosaurs never saw it coming. They ruled the Earth for over 160 million years, longer than humans have existed by far, and yet their reign ended in a single day, snuffed out by a rock from space. If it happened to them, it can happen to us. Our skyscrapers, our technologies, our civilizations may feel invincible, but in the face of a cosmic strike, they are as fragile as the forests flattened at Tunguska. Cosmic strikes are the universe's way of reminding us that Earth is not isolated, not safe, not untouchable. It is part of a violent cosmos where chance encounters can decide the fate of entire worlds. Every crater on Earth is a reminder of past impacts, every shooting star a reminder of the debris still circling above. The next strike may be centuries away, or it may be tomorrow. The only certainty is that the cosmos does not care, and in that indifference lies the greatest danger of all. Life on Earth often feels eternal, as if the forests, oceans, and creatures we see around us have always been here and always will be. But the truth is far more unsettling. Our planet has a history written in cycles of life and death, of flourishing abundance followed by sudden collapse. Extinctions are not rare accidents. They are woven into Earth's story, striking with a regularity that seems almost fated. Each cycle of destruction has reshaped life, clearing the stage for new actors, while erasing entire worlds that will never return. And as history shows, no species, no matter how dominant, is immune from these cycles, not even us. The most dramatic examples are the so-called Big Five mass extinctions, the great die-offs that reset life's balance again and again. The first occurred over 440 million years ago, during the Ordovician period. At that time, the seas were thriving with strange marine creatures, trilobites, brachiopods and jawless fish. Then in a geologic instant, ice ages swept across the planet, dropping sea levels and freezing ecosystems into silence. Nearly 85% of marine species vanished, their reign cut short by a climate shift they could not survive. It was the first great warning: life, no matter how successful, can be undone in a moment by forces far beyond its control. Roughly 70 million years later, the Devonian extinction struck, wiping out 75% of species. This one unfolded in waves, a slow collapse driven by changes in oceans, perhaps triggered by massive plant growth on land. As plants spread, they altered the atmosphere and drew down carbon dioxide, changing the chemistry of the seas. Oxygen levels dropped, suffocating marine life in vast dead zones. Coral reefs, once vibrant, withered away, and entire families of fish disappeared forever. What made this extinction so chilling was not its suddenness, but its persistence. Life was strangled gradually, wave after wave, until the seas became graveyards. But even those disasters pale compared to what came next. The Permian-Triassic extinction, often called the Great Dying, about 252 million years ago, something possibly massive volcanic eruptions in Siberia, methane releases, or even an asteroid impact, triggered the deadliest extinction event in Earth's history. Over 90% of species perished, forests vanished, oceans turned toxic, and the very air became poisonous. Trilobites, which had survived for hundreds of millions of years, finally went extinct. The Earth was reduced to a wasteland, where survival itself seemed impossible. For a time, life on Earth nearly ended. It was the closest our planet has ever come to being truly dead. And yet, against all odds, life clawed its way back from the brink. The Triassic extinction followed 50 million years later, caused by volcanic activity and climate shifts. Again, species that had begun to recover were wiped out. But this extinction carried an unexpected twist. It cleared the stage for the dinosaurs. Without the collapse of older competitors, dinosaurs may never have risen to dominance. This is the cruel paradox of extinctions. While they erase, they also create opportunity. Every mass death opens a door for survivors to thrive in a new world, one shaped by absence as much as presence. The fifth of the great extinctions is the most famous, the one that ended the age of dinosaurs. 66 million years ago, as a giant asteroid slammed into Earth, the reign of these colossal creatures came to a sudden and fiery end. But while dinosaurs perished, small mammals, once overshadowed and insignificant, seized the opportunity. From their survival, the lineage that would eventually give rise to humans began its rise. Without that extinction, we might never have existed. What makes these cycles so haunting is that they seem to follow patterns, as if Earth itself is locked into a rhythm of destruction. Some scientists speculate about periodic causes, cosmic cycles that bring waves of asteroids, or geological cycles that destabilize the planet every few 100 million years. Others argue that randomness is enough, that Earth is simply too chaotic for stability to last. Either way, the result is the same: mass death, followed by renewal. Life flourishes, collapses, and flourishes again, in a never-ending cycle. And extinction is not always global. Even between the great die-offs, countless smaller extinctions punctuate Earth's history. Entire species vanish daily, often without notice, leaving behind no legacy but bones in the ground. The fossil record is filled with names of creatures that once thrived but are now gone forever. Saber-toothed cats, woolly mammoths, giant ground sloths, all victims of the most recent extinction events driven not by asteroids or volcanoes, but by humans. This is perhaps the most chilling realization. We are not just witnesses to extinction cycles, we are participants. Human activity, deforestation, overhunting, pollution, and climate change is now driving what many scientists call the sixth mass extinction. Species are disappearing at rates thousands of times faster than natural background levels. Rainforests, coral reefs, and countless habitats are collapsing. And unlike past extinctions which unfolded over millennia, this one is happening within centuries, within the span of a single human civilization. For the first time, extinction is not only a natural force, but a man-made one. The irony is impossible to ignore. Extinctions created the conditions that allowed humans to exist. Now humans, in turn, are driving extinctions at a pace Earth has rarely seen. We are both the product of past cycles and the agents of a new one. The question is whether we can break the pattern, or whether we will ultimately fall victim to the same fate as the dinosaurs. After all, dominance offers no protection. The oceans once belonged to trilobites. The land once belonged to dinosaurs. The skies once belonged to giant pterosaurs. All of them are gone. And humans, despite our intelligence and technology, are not immune. Extinction cycles also carry a deeper lesson about resilience. Life does not end, it transforms. After every collapse, survivors adapt, evolve, and flourish in the changed world. New species rise, filling the void left by the old. Coral reefs return, forests grow back, and ecosystems reassemble in ways both familiar and alien. Extinction is not just an end, but a reset. The planet has endured 5 global resets already. Whether it endures a 6th depends on whether we learn to respect the fragile balance that sustains us. The unsettling truth is that the story of life is not one of permanence, but of constant reinvention. What feels stable today, our cities, our technologies, our species, may be nothing more than a temporary chapter in Earth's larger story. The cycle will continue, with or without us. We are at best passengers on a planet that has proven time and again that it does not hesitate to erase its inhabitants when balance is broken. And so the real question is not whether another extinction will come. It will. The question is whether we will adapt, survive, and shape the next chapter, or whether we will join the countless species already written into the fossil record. For now we live in the space between cycles, a fragile moment of life's triumph. But as Earth's history shows, that triumph is always temporary. Deep beneath our feet lies a world we rarely think about, a hidden realm of molten rock, shifting plates, and pressures so immense they can shatter mountains in seconds. The solid ground we trust every day is an illusion, a thin crust floating on a restless interior. Earthquakes and volcanoes are the violent reminders of this truth, moments when the calm surface gives way, and the fire below bursts through, reshaping landscapes and rewriting history. They are forces of both creation and destruction, sculpting continents, building islands, and at the same time tearing apart cities and ending lives without warning. To live on Earth is to live on borrowed peace, for the fire below is always waiting. Earthquakes are among the most terrifying of natural disasters, precisely because they strike without notice. Unlike storms which gather slowly, or volcanoes which show signs of rumbling before they erupt, earthquakes erupt in silence. A fault line slips, a section of crust grinds, and suddenly the ground shakes with a power that dwarfs anything humans can build. Buildings collapse, bridges crumble, and in an instant, the illusion of stability is broken. The 2011 earthquake in Japan, one of the strongest ever recorded, unleashed a tsunami that killed tens of thousands and triggered a nuclear disaster. In Haiti in 2010, A 7.0 quake reduced the capital city to rubble, killing over 200. These are reminders that beneath even the most populated cities, ancient scars in the earth wait patiently, releasing their energy when the pressure becomes too great. Volcanoes, on the other hand, announce themselves with spectacular fury. They are the Earth's vents, the places where molten rock and gases trapped within the mantle force their way to the surface. When they erupt, they do so with unimaginable violence. Explosions so loud they can be heard thousands of kilometers away. Ash clouds that blot out the sun, rivers of lava that devour everything in their path. The eruption of Mount Vesuvius in 79 AD buried the Roman cities of Pompeii and Herculaneum under meters of ash, preserving their citizens in frozen moments of terror. The 1815 eruption of Mount Tambora in Indonesia caused what became known as the Year Without a Summer, as volcanic ash circled the globe, blocking sunlight and plunging much of the world into famine. What makes earthquakes and volcanoes even more haunting is their connection. Both are driven by plate tectonics, the slow grinding movement of Earth's crustal plates across the mantle. Where plates collide, mountains rise, but they also shatter, creating fault lines ripe for earthquake. Where plates diverge or subduct, volcanoes form, tapping into reservoirs of molten rock that can explode with catastrophic force. The so-called Ring of Fire, encircling the Pacific Ocean, is a testament to this restless energy. Home to most of the world's earthquakes and volcanoes, it is a reminder that civilization has always been built on shaky foundations. Cities like Tokyo, San Francisco, Manila and Santiago exist in constant shadow, knowing the ground beneath them is never truly stable. Yet these violent forces are not merely destructive. Without them, Earth would be a dead planet. Volcanoes release gases that helped form the atmosphere, including carbon dioxide that plants use to grow. Lava, once cooled, creates rich soils that support agriculture and life. Entire islands like Hawaii exist only because of volcanic eruptions that built mountains from the seafloor upward. Earthquakes, though deadly, are also part of the process that recycles the crust, driving continents to drift and oceans to open and close. Without this movement, Earth's surface would stagnate, and the cycle of renewal that fuels life would cease. The paradox is clear. The same forces that kill also give life, balancing destruction with creation in ways humans rarely appreciate until disaster strikes. Throughout history, humans have viewed these events with awe, fear, and reverence. Ancient myths often linked volcanoes to gods of fire and chaos. The Greeks believed Hephaestus forged weapons beneath Mount Etna. Pacific Islanders told stories of Pele, the goddess of volcanoes, whose fiery temper could both bless and destroy. Earthquakes, too, became part of mythology. Some saw them as the footsteps of giants, others as the anger of gods shaking the earth in rage. Even today, the raw spectacle of an eruption or the sudden violence of an earthquake carries a mythic weight, reminding us that despite all our science, some forces remain untamed. Modern science has given us tools to monitor these events, but prediction remains elusive. Seismographs can record tremors, satellites can track volcanic swelling, and sensors can detect gases, but no system can say with certainty when the next eruption or quake will come. This unpredictability keeps millions of people living in the shadow of disaster, knowing their lives could change in seconds. The people of Naples live with Vesuvius looming nearby. Tokyo prepares endlessly for the big one, and the residents of Iceland accept that volcanoes beneath their feet could erupt at any moment, disrupting not only their lives but air travel and economies across the globe. The most chilling possibility comes from supervolcanoes, massive volcanic systems capable of eruptions far beyond anything in recorded history. The Yellowstone caldera in the United States, for example, has erupted 3 times in the last 2 million years, each event spreading ash across continents and altering global climate. If it were to erupt again, the effects would be catastrophic on a planetary scale, blocking sunlight, collapsing agriculture, and triggering famine worldwide. Humanity has never faced such an event, but the potential exists, and it hangs over us like a silent threat. Earthquakes, too, carry apocalyptic potential. A megathrust quake along the Cascadia subduction zone off the Pacific Northwest coast could generate a tsunami powerful enough to devastate cities from Seattle to San Francisco. Scientists know the fault is locked and building pressure. The only uncertainty is when it will slip. The destruction would rival any disaster in history, leaving millions homeless and reshaping the region permanently. Such events remind us that for all our engineering and technology, we remain vulnerable to the restless forces beneath our feet. And yet, as devastating as they are, earthquakes and volcanoes also symbolize resilience. After every eruption, new land is formed, new life grows. After every quake, cities rebuild, stronger and more determined. In Iceland, communities harness geothermal energy from volcanic systems to power their lives. In Japan, centuries of quakes have shaped a culture of preparedness, engineering buildings to sway rather than collapse. Humanity adapts, even in the face of fire and stone. These disasters may humble us, but they also force innovation and resilience, driving us to survive against odds that seem insurmountable. What makes the fire from below so captivating is its duality. It is both enemy and ally, destroyer and creator. It builds the mountains we marvel at, fertilizes the soils we depend on, and powers the geothermal systems that sustain cities. But it also claims lives, erases civilizations, and reminds us that we are small creatures on a restless planet. The Earth is alive, and its heartbeat is felt in the tremors of quakes and the eruptions of volcanoes. To ignore that is to forget where we came from, and to underestimate the forces that still shape our destiny. In the end, earthquakes and volcanoes tell the same story as every force of nature we've explored. The story of balance. For life to exist, the Earth must move, shift, and change. Stability is an illusion. Chaos is the truth. To live here is to live with the fire below, knowing it could erupt at any moment, yet also knowing that without it there would be no forests, no oceans, no humans. We are children of a planet that is constantly reshaping itself, and whether we survive the next great eruption or quake will depend not on conquering the fire, but on respecting it. When we imagine Earth's most violent forces, we often think of fire, quakes, or storms. But sometimes destruction arrives in silence, creeping slowly until entire worlds vanish beneath its grip. Ice ages and climate shifts are the planet's cold disasters, moments when glaciers expand like armies, seas retreat, and entire species are locked out of existence. These frozen catastrophes may not roar with the fury of a volcano or strike with the speed of an earthquake, but their power is no less profound. They grind mountains into dust, rewrite coastlines, and decide the rise or fall of civilization. And unlike sudden disasters, these are battles humanity often does not even realize it is losing until it is far too late. Ice ages are periods when vast sheets of ice spread across continents, trapping water, lowering sea levels, and altering the face of the planet. Over the last 2.5 million years, Earth has cycled through repeated ice ages, with glaciers advancing and retreating in rhythm with changes in the planet's orbit, tilt and wobble. During the peak of the last ice age around 20,000 years ago, ice sheets stretched across North America, Europe and Asia, burying landscapes under kilometers of frozen weight. Mammoths, saber-toothed cats, and giant sloths roamed icy plains, while human tribes huddled in caves, their survival hanging by a thread. For thousands of years, glaciers sculpted valleys, carved lakes, and shaped the geography we recognize today. But the ice was merciless. Entire species could not adapt to the cold, disappearing forever. Ecosystems shifted as tundra replaced forests, and oceans withdrew as water locked into glaciers, lowered sea levels by more than 100 meters. Land bridges emerged, most famously, the Bering Land Bridge connecting Asia to North America, allowing humans and animals to migrate into new worlds. These frozen catastrophes were not only destructive, they were also doorways, opening paths that would change the course of human history. Without the Ice Age, the Americas might never have been populated, and the story of civilization would look very different. What makes ice ages particularly unsettling is their regularity. They are not random, they are part of Earth's natural rhythm, tied to the cycles of our orbit around the Sun. These cycles, called Milankovitch cycles, dictate when ice expands and retreats. It means that even without human influence, Earth is destined to shift between warm and cold ages, with each swing reshaping the planet in its own way. The glaciers are not gone, they are simply waiting, poised to return when the cycles align once more. And yet, the last retreat of the glaciers brought with it one of the greatest transformations in human history. As the ice melted around 12,000 years ago, the world warmed, seas rose, and fertile plains emerged. Rivers swelled with glacial meltwater, feeding lands that became cradles of agriculture. This sudden abundance allowed humans to settle, build, and eventually form civilizations. In a strange paradox, the end of the last ice age may have been the birth of everything we call history: writing, cities, empire. Without the glaciers withdrawing, humanity may never have risen beyond scattered tribes. The ice age was both a tormentor and a gift. But the story of frozen catastrophes does not end with ice alone. Climate shifts, sudden and often unexpected, have also pushed humanity to its limits. History is filled with moments where small changes in temperature, rainfall, or wind patterns toppled entire empires. The Little Ice Age, a cooling period from the 14th to the 19th centuries, brought bitter winters, failed harvests, and famine to Europe. Rivers froze, crops failed, and societies strained under the weight of hunger and disease. Famines led to uprisings, wars, and the collapse of states unprepared for a world that had suddenly turned colder. On the other side, warming has been just as disruptive. Periods of drought have ended civilizations as surely as armies. The mysterious collapse of the Mayan civilization has been linked to prolonged droughts that dried their reservoirs and left once great cities abandoned. Ancient Mesopotamia, cradle of civilization, suffered devastating shifts in rivers and rainfall that undermined agriculture and destabilized kingdoms. For all humanity's achievements, history shows again and again that we are, and always have been, servants of climate. What makes climate shifts so terrifying is their unpredictability. Unlike the slow cycles of ice ages, sudden changes can happen within decades, faster than civilizations can adapt. Volcanoes can trigger volcanic winters by spewing ash into the atmosphere, cooling the planet for years. Ocean currents can shift, redirecting heat and plunging regions into chaos. Even small fluctuations, just a few degrees colder or warmer, can decide whether crops thrive or fail, whether populations grow or starve. For humans who depend on stability to build societies, these frozen catastrophes are as dangerous as any asteroid or quake. Today, the spectre of climate catastrophe looms again, but this time it is not glaciers advancing from the north. It is heat. Human activity, the burning of fossil fuels and release of greenhouse gases, is shifting Earth's climate at a speed unseen in natural history. Glaciers are melting faster than expected, seas are rising, storms are intensifying, and ecosystems are collapsing. The frozen catastrophes of the past remind us that even natural cycles were enough to reshape the world. But now humanity has become the driver of change, accelerating processes that once took millennia into mere centuries. The danger is not just in rising temperatures, but in the chaos of unpredictability: drought in one region, floods in another, storms in places once calm, and ice sheets collapsing with consequences that ripple across the globe. The melting of glaciers today is especially haunting. These ancient giants hold not only water but history. Trapped within their ice are bubbles of atmosphere from ages past, records of climates long gone. As they melt, they release more than water. They release stories, data, and sometimes even bodies of creatures and humans preserved for thousands of years. Each collapse of ice is a reminder that the frozen past is slipping away, and with it the stability humanity has relied on. If the Greenland and Antarctic ice sheets were to melt completely, sea levels would rise by tens of meters, drowning coastal cities and displacing billions. Entire nations would vanish beneath the waves. Frozen catastrophes are not as dramatic as explosions or storms, but their reach is greater. They change coastlines, redraw maps, and dictate the fate of civilizations. They creep silently, without the roar of thunder or the flash of fire. But in the end, their power is absolute, and unlike a storm that passes or an earthquake that ends, climate shifts can linger for centuries, reshaping the lives of countless generations. Yet, as with every disaster, there is resilience. Life adapts. Humans survived ice ages by learning to make fire, craft tools, and build shelters. Civilizations that faced droughts developed irrigation, trade, and migration. Even today, humanity is searching for ways to adapt to the warming world through renewable energy, technology, and perhaps even geoengineering. The question is whether we can act fast enough, or whether we will once again find ourselves at the mercy of Earth's frozen catastrophes. The greatest lesson of ice ages and climate shifts is that nothing is permanent. The world we know, its rivers, cities, and climates, is temporary. It can freeze, thaw, or collapse at any moment. Humanity exists in a brief window of stability, a pause between catastrophes, And how long that pause lasts depends not just on nature, but on us. Frozen catastrophes remind us that Earth's power is not always violent. It is also cold, patient, and inexorable. And when it decides to move, nothing can stand in its way. For most of history, humanity lived in fear of Earth's power. The fire of volcanoes, the fury of storms, the shifting ground beneath our feet, all reminded us that survival was never guaranteed. But in the last few centuries, something changed. Humans stopped simply enduring nature's wrath and began to believe we could master it. We built dams to tame rivers, levees to hold back seas, skyscrapers to reach into the sky, and machines to pierce the crust in search of oil and minerals. We dug deeper, built higher, consumed faster, and spread further than any species before us. And in doing so, we made a gamble that Earth would bend to our will, that the planet's vast forces could be controlled, harnessed, or at least ignored. It is the boldest wager in history, and perhaps the most dangerous. Our gamble begins with resources. Every civilization depends on the land beneath it, but modern humanity has taken that dependence to extremes. We drill into the earth for oil and gas, tearing ancient carbon from rock and burning it into the skies. We strip forests bare, replacing them with cities and fields of single crops. We mine rare minerals, gouging scars into mountains to feed our hunger for technology. On the surface, it looks like progress, energy, wealth, and growth. But beneath, we are destabilizing systems that took millions of years to form. By releasing carbon stored for eons, we have altered the chemistry of the atmosphere in just a few generations. The gamble is clear. Can Earth's balance survive our appetite, or will the very systems we depend on collapse under the strain? The gamble extends into where we live. Instead of avoiding danger zones, humanity builds directly in them. Cities sprawl across coastlines vulnerable to storms and rising seas. Skyscrapers rise along fault lines where earthquakes are inevitable. Populations expand into floodplains, deserts and forests, turning once natural buffers into ticking time bombs. New Orleans was built in a bowl below sea level, reliant on levees that eventually failed. Tokyo, one of the largest cities in the world, sits above some of the planet's most active fault lines. In our drive for growth, we have staked our future in places where disaster is not a possibility, but a certainty. Our confidence is breathtaking, but it is also reckless. Technology, too, is part of our gamble. We have harnessed the atom, unleashing energy that rivals the fire at Earth's core. Nuclear power promises clean energy, but accidents like Chernobyl and Fukushima reveal the consequences when control slips. Nuclear weapons, our most terrifying invention, hold the power to erase humanity in a flash, rivaling even cosmic impacts in destructive potential. In our quest to dominate nature, we created tools that could end not just civilizations, but the species itself. This is perhaps the most dangerous gamble of all, trusting ourselves with powers greater than the forces we once feared. Climate change is the ultimate expression of humanity's gamble. For millennia, Earth's climate shifted naturally, bringing ice ages and warm periods over slow geological timescales. But in just 2 centuries, humanity has altered the atmosphere so drastically that glaciers are melting, seas are rising, and weather is becoming increasingly chaotic. We have turned the planet into an experiment, changing conditions that support life without fully understanding the consequences. Scientists warn of tipping points, moments when Earth systems could spiral beyond our control, triggering runaway warming, collapsing ecosystems, and mass extinction. Yet despite the warnings, the gamble continues, fueled by industries, governments, and billions of people unwilling to abandon the comforts progress has given them. And the gamble is not limited to the environment. By pushing deeper into Earth's systems, we risk triggering consequences we barely understand. Fracking, the process of extracting natural gas by fracturing rock deep underground, has been linked to earthquakes in regions once considered stable. Deforestation not only destroys habitats, but alters rainfall patterns, disrupting weather thousands of kilometers away. Massive dams, while providing power and water, can change the flow of rivers so drastically that entire ecosystems collapse. In each case, we act as though Earth is a machine to be manipulated, forgetting it is a living system of interconnected forces. Pull one lever and another shifts. Push too hard and something breaks. But perhaps the most unsettling aspect of humanity's gamble is the illusion of control. We tell ourselves we are masters of technology, that science and innovation will solve any crisis. When seas rise, we will build walls. When deserts expand, we will engineer crops. When storms intensify, we will design stronger buildings. This optimism fuels progress, but it also blinds us to limits. No wall can hold back an ocean that rises by meters. No technology can replace the biodiversity lost when rainforests vanish, and no amount of engineering can reverse tipping points once they are crossed. The belief that we can outsmart Earth is part of the gamble, but history shows the planet always has the final word. And yet, it would be wrong to paint humanity's gamble only as arrogance. It is also born of survival. From the moment we first struck flint to create fire, we have fought to carve out safety in a world of chaos. Agriculture, cities, medicine, industry. All are attempts to protect ourselves from nature's unpredictability. The gamble is risky, but it has given us wonders, longer lives, art, science, exploration, and the ability to look beyond Earth itself. We are the first species to dream of leaving the planet, not just surviving its whims, but seeking new worlds beyond. The gamble has allowed us to rise, but whether it sustains us or destroys us remains the unanswered question. The irony is that, in trying to dominate Earth, we may have set ourselves on a path toward our own extinction. History has shown that every dominant species eventually falls: trilobites, dinosaurs, mammoths. What makes us different is not immunity, but awareness. We know the risks of our actions. We understand the science of climate, tectonics, and ecosystems. We can predict disasters in ways no species before us could, and still we continue the gamble. This awareness makes our situation unique. We are not only players in Earth's cycles, but conscious gamblers, aware of the stakes and choosing to roll the dice anyway. So what happens if humanity loses? If seas swallow coastal cities? If food systems collapse under climate stress? If war breaks out over dwindling resources? It will not be the end of Earth. The planet has survived worse asteroid impacts, supervolcanoes, and extinctions, far more severe than anything humans could trigger. The Earth will endure. Life will adapt. The gamble is not about Earth's survival, it is about ours. If we fail, we will be written into the fossil record alongside trilobites and dinosaurs, a brief experiment in intelligence undone by its own ambition. But what if humanity wins? Or at least learns? The gamble does not have to end in ruin. Our awareness gives us a chance no other species has had: the ability to recognize danger and change course. Renewable energy, conservation, sustainable agriculture, and global cooperation are steps toward a new way of living with Earth instead of against it. The gamble has always been about whether we can bend the planet to our will. Perhaps the true victory lies not in bending Earth, but in bending ourselves to adapt, to respect, and to find balance within the planet's limits. In the end, humanity's gamble is the greatest story ever told. It is the story of a species that rose from caves to cities, from fire to rockets, daring to believe it could master the very planet that gave it life. It is a story of brilliance and blindness, of progress and peril, and it is a story still being written. Every decision we make, every resource we consume, every technology we create, adds another turn to the wheel of chance. Will we emerge as the first species to transcend extinction, or will we fall like all the others, another victim of Earth's relentless cycles? The answer lies not in the ground below or the skies above, but in ourselves, and whether we are willing to face the risks of the gamble we've made. After exploring the storms, the quakes, the ice, and the fire, one truth rises above all others: Earth is not a passive backdrop to humanity's story. It is the central character. For billions of years, it has created, destroyed, and reshaped life in endless cycles, and it will continue to do so long after we are gone. We often speak of saving the planet, but the reality is that Earth does not need saving. It has survived impacts that boiled oceans, extinctions that erased nearly all life, and climate shifts that turned forests into deserts. What is fragile is not the planet itself, but our cities, our civilizations, our fragile web of technology and agriculture, all exist at the mercy of forces we cannot tame. The gamble we've taken, the risks we've ignored, and the systems we've disrupted have placed us not above Earth, but squarely within its grasp. The conclusion is both sobering and humbling. Every great civilization before us thought it would last forever. The Romans believed their empire eternal. The Mayans built vast cities with faith in their endurance. The Egyptians carved monuments into stone to outlast the ages, and yet all of them fell, some to war, others to famine, others still to climate and environment. If history whispers a warning, it is this: arrogance is always punished. The earth does not bend to human ambition, it simply waits, and when balance is broken, it restores itself in ways we cannot anticipate or control. And yet within that warning lies a strange kind of hope. Humanity is the first species in Earth's long history to truly understand its place in the grand cycle. We know how impacts have shaped life, how volcanoes built continents, how ice ages sculpted valleys, and how extinctions cleared the stage for new beginnings. This knowledge gives us something no other species has ever possessed: the chance to anticipate, to adapt, and perhaps even to endure where others could not. The question is not whether Earth will continue, it will. The question is whether we will learn to live with it, not against it. The future is uncertain, but it is not written in stone. It may hold storms more violent than we've ever seen, seas that rise higher than our tallest defenses, or quakes that reduce our greatest cities to dust. It may also hold breakthroughs, technologies that allow us to adapt, cooperate, and thrive even in the face of chaos. Humanity's story is not yet finished, but the ending depends on whether we heed the lessons carved into the very bones of our planet. Will we become another chapter in the long history of extinctions, or will we finally break the cycle, proving that intelligence can coexist with humility? What is certain is that Earth will outlast us. The forests may regrow over our ruins, the seas may reclaim our coasts, and the skies will continue to shift with storms and stars. Long after our monuments crumble and our names are forgotten, Earth will remain restless, alive, and ever-changing. In the end, the conclusion is not about conquering the planet, but about remembering our place within it. We are passengers on a living world, fragile guests on borrowed time, and perhaps the most important choice we face is whether to gamble recklessly until the Earth erases us, or to live in awe and respect of the power that has always held our fate.